All right, this is the second part of the notes, 3.2, and this is on elimination specifically. So the elimination method is the third way that we can solve a system. And if you remember, a system of equations just means we have more than one line. That's all that means. So if you think about eliminating something, then when we eliminate something, this just means we get rid of it. So what we're going to do when we eliminate is we're going to eliminate a variable with our two equations. So the first thing that we have to do is we have to put both equations in standard form. Now, what that means is ax plus by equals c, or ax plus by plus c, let me write this down because you can do it this way too, equals 0. So either one of those is going to be standard form. Normally, we're just using this top one up here, okay? The next thing is you need to get one of the variables, just one of them, to have the same coefficient. I-E-N-T, sorry, spelled that wrong. All right, and so what the same coefficient is that's the number that's before the variables. So here my coefficient's 3. Here my coefficient's 2. Here my coefficient's 4. Here my coefficient's -2. Okay? So you need to get one variable with the same coefficient, but opposite sign. So this one's perfect. This is 2y, oops, sorry. This is 2y and this is -2y. So same coefficient, opposite signs. Right? Now, what this says is you might need to multiply one or both of the equations by a constant so that you can change these. If you look down here at part B, this is 3, this is 6, this is -7, this is -8. None of these are the same like they are up here. Okay, so once you've multiplied through and you see two coefficients with opposite signs, you're going to add the equations. You're then going to solve for the remaining equation. And then what we just did is we're going to substitute back in to solve for the other variable. Okay, so if we look at letter A here, I am going to add these up. And the reason I can do that is because these two are going to cancel out. So if I add up, I have 7x equals -7 because 2 minus 2 goes away. So x equals -1. Now, when I plug this back in, I have 3 times -1 plus 2y equals 1. So now I'm substituting, so I'm up here back at 5 already. I'm substituting x equals -1 into either equation. It doesn't matter which one you pick. So I have -3 plus 2y equals 1. So 2y equals 4 and y equals 2. And again, just like with substitution, these have to be ordered pairs. So my solution here is -1, 2. Okay, the next one that we have looks like this. So if I look at what's the easiest thing to do, the easiest thing to do is to take this top equation and multiply it by a -2. If I multiply it by a -2, then I end up with -6x on the top and positive 6x on the bottom. Now, there's nothing I can do with the 7 to turn it into an 8. When I multiply through by a negative, I'm going to multiply the entire equation, even the other side of the equal sign. So when I do this, I would have -6x plus 14y equals -20. And then I have my original equation, which is my second equation, 6x, oh, I forgot my y, minus 8y equals 8. And now I'm going to add those two up. So I have 14y minus 8y. So this gives me 6y equals -12. Okay, so when I solve this, I get y equals -2. Now again, I'm going to take this and I'm going to substitute it back into either equation. So I'm going to do this, I'll do the bottom one, I guess. I have 6 times negative 2 minus 8y equals 8. So negative 12 minus 8y. I'm going to take this 12 and add it to the other side. So negative 8y equals 20. Oh no, you know what I did? Ha ha ha. I have this negative, I have y equals negative 2, and I just plugged it in for x. So hold on. I'm going to erase this. Hopefully you caught what I did. Let's go back and fix this. I have 6x minus 8 times negative 2 equals 8. This was y, so I have to plug it in for y. So 6x plus 16 equals 8. So 6x equals 24, so x equals 4. So my final answer here is going to be 4, negative 2. Make sure I did this right. 6x plus 16 equals 8. Oh my gosh, y'all, I'm struggling. I knew that didn't look right. I'm going to subtract here. Hello, so minus 16. So 6x equals minus 8. There we go. So negative, this becomes a positive 16, so I have to subtract 16. I get negative 8, so I have x equals negative 8 over 6. And that reduces. Okay, so now what we're going to do is we're going to add on to this just a little bit. So if we look at this next page, what happens here is on this problem, there's not an easy answer to get any of these solved. So what happens is there's not anything I can multiply my x's by or my y's by to get something to cancel out. So because this is positive and this is negative, I'm going to multiply the top by 4 and I'm going to multiply the bottom by 3. And the reason why I did that is because I see that this would be 12x and this would be negative 12x. And when I do that, my x's are going to cancel out. So I'm going to distribute this 4 to both sides of the equation. 12x minus 24y equals 36. And then here on the bottom, what I have is minus 12x plus 21y equals negative 48. Okay, now I'm going to add these up. And so as I add this up, this becomes negative 3y because these cancel out. And then on this side, I'm going to have negative 8. Right? Oh my gosh, I'm struggling. So 48 minus 36, no, it's going to be 12. Negative 12. So y is going to equal 4. So if y equals 4, I'm going to plug it back into one of my equations over here. So 3x minus 6 times 4 equals 9. So 3x minus 24 equals 9. So now I'm going to add 24 to both sides, and I have 3x equals 33, so x equals 11. So my answer here would be 11, negative 4. Okay. Now, with these last two, there isn't anything different in these last two equations. We've multiplied one by a negative. We've multiplied one by two different numbers. And so now what's going to happen is we're going to multiply this top equation by a negative 3. And if I multiply this by a negative 3, I see I have negative 6x and positive 6x. But something else is going to happen on this one. So let's try this out. I have negative 6x minus 15y equals negative 24. My bottom equation doesn't change. So now I'm going to add this up. So my x's go away, but look what happens. My y goes away. So when all of this happens, that means the left side of my equation is 0. Everything has canceled out. It doesn't just go blank. I have to have something there, so it becomes a 0. And this is going to equal negative 4. So now I have this dilemma. This says 0 equals -4, but this is not true. 0 does not equal -4. So because this situation is not true, this says I have no solution. And if you remember, something that has no solution, what this is really saying is that this is going to be two parallel lines. And so if I have two parallel lines, they're never going to cross, and that's what this is saying. Saying it's no solution, so these lines are just parallel. All right, let's go down here and do the last one. So I see a 2x and a -4x, so I'm going to multiply this whole guy by -2. So I have -4x minus 10y equals -16. And on the bottom, oh, hold on. I don't want to do that. I want to multiply that by a positive 2. Because if I multiply this by a positive 2, 4x plus 10y equals 16. Now I'm going to subtract. So minus 4x minus 10y equals -16. Okay, I'm going to add these up. This is 0. This is 0. So I have 0 on the left side. And now I have 16 minus 16. This is 0. Well, now we have a different scenario than we have up here, right? So this said 0 equals -4, which is not true, but 0 does equal 0. This is true. So when this happens, what this is saying is I can take any value of x, any value of y, and plug it into both equations, and I'm going to end up with the same answer in either equation. So because this is true, this is going to be infinite solutions or all real numbers. Either way that you want to do this. And again, what this means is if I rearrange these, this is going to be same line. That's what that's telling us. And you know, I'm drawing this as a line that has a positive slope, but I can tell you this line up here, just knowing this is going to have a negative slope, and this is also going to have a negative slope. So when I draw this as same line, that's not what the line's really going to look like. I'm just trying to help you visualize the fact that parallel lines have no solution, and one line would be same solution. Okay, we're going to do a lot of practice on this.